4. So we have limit as x approaches 4 from 1/2 x minus 1 equals 1. I have to state a definition. And again, we're going to answer any question at any point in time. I'm just going to say that this is the easiest thing in the entire course, and you will notice that a little bit later. Right now, it looks difficult, but you will see later on, you'll say, oh, gee, this was the easiest. So we have to write the double equivalency. For every epsilon greater than 0, which is positive, there exists a delta greater than 0, such that every time we pick close to 4, x minus 4, so this is the distance between x and 4. That's what it is. Less than delta, this will always imply that the f of x, f of this x minus the limit in absolute value has to be less than epsilon. Oh, I'm sorry. I'm sorry. I realize that. Oh, I realize that. What is going on? No glitches, please. No glitches. Okay, so this is the distance between f of x and epsilon. I'm sorry, and the limit, of course, which has to be less than epsilon. And 1, which is the limit. Let me make sure this is clear. And there is no misunderstanding. Okay, so we start here, where we have f of x, which is 1/2 x minus 1 and minus 1, less than epsilon. This is 1/2 x minus 2, less than epsilon. We have the least common denominator, x minus 4, and this is exactly what I want.
Will we get marked down points if we do f of x minus 1 instead of putting the actual function?
You mean here?
Yeah.
You can put f of x, or you can put 1/2 x minus 1.
Okay.
Okay, so then I have to write x minus 4 in absolute value over the absolute value of 2. Then you have to write the absolute value of x minus 4 over 2 less than epsilon. Then we multiply both sides by 2, and we get less than 2 epsilon. So then, therefore, delta must be 2 epsilon. And then you reverse for step 2. Is this okay?
Could you hold on for a second? I'm just trying to write all this down.
Oh, yeah, sure. Remember, this will be posted after class.
Could you move up the paper real quick so you can see the top of it? Yeah, thank you.
Again, all this will be posted after class, so you know. Is this okay now? Anyone? Is this okay?
Sorry. Just a moment.
Which step of all these you think is difficult? Because this part is just plain algebra.
It's just copying.
Say it again?
We're just notating it. I mean, we've got to go through the steps here. Or at least I do, to write it down.
Okay, that's absolutely fine. But my question is, did anyone look at these problems, the 20 that we did last time, and what was the other one? And 17? Did you get the chance to look at 20 and 17 from last time?
The other example, just like this, right?
Yeah.
Yeah.
Okay. Good.
After this, could we do an error one with the delta?
Yes.
Yeah.
Okay, which one? We did this one last time.
Could you scroll up, please?
Okay.
Okay, we could do the second one then.
So here it's only asking us which delta will you pick. The calculations are already done. Which delta will you pick?
Okay, yeah, then let's do a different one then.
Yeah, a different one.
Okay, which delta will you pick on this one? Can anyone say which delta will you pick? How much is epsilon in this problem?
2.6.
How much is epsilon in this problem?
Would be 0.4.
Point careful. How much is epsilon in this problem? 0.5, excellent. And how much is the correct delta for this problem?
0.4.
0.4, because you are comparing the 0.4 with 0.8. Which one do we have to pick?
0.4.
0.4. Good?
Are there going to be problems where we have to calculate, where we have to find both deltas, like delta 1 and delta 2?
If
Or we
you
actually
don't
have to, like,
if
do
you
the
don't have
calculations to
if you
find-
don't have both, you will not be able to choose.
Yes, but can we do the calculations to find them? Whereas this one, they're already provided?
Yes, we already did this. Yes.
Okay.
So the calculations here are 0.4 and 0.8, and we have to choose 0.4. On this problem, we determined this number, and we determined this number, and we had to choose. Here, those numbers were given to us. And here we had to determine them and then choose. So this is one step forward. Okay, so is this what you had in mind?
Yes, number 4.
Okay, so let's look at number 4. Again, as I mentioned, I will answer any questions, but this is not the most important topic, and I would like to move on, but I'll answer any questions. Good, so this is the same question, basically. So then, can anyone give us the epsilon?
1/2.
Yes, the epsilon is 0.5 or 1/2. Perfect. So the function is y equals x squared. So then we are looking at this function, which is x squared. And we have, this is 1. The limit is 1, and x is also 1. So we have
Sorry, we can't see your writing.
Give me just 1 second to copy. I did copy it. That's all I needed. Sorry. Good. So we have here 1.5, and we have here 0.5. This point and this point. So we need to identify what we get for x. So there is an x squared, which is 1.5. For some x, I get 1.5. And for some other x, I get 0.5. What do I do now? To find this value and find this value. What should I do here? How do I solve these equations for x?
Would you plug it in for x? So would you plug 1.5 into it?
How do I solve this equation for x?
Square root both
It's the
sides.
square
Thank
root
you.
of
Thank you.
1.5.
So the square root of 1.5, I got 1.2247. So this piece is 1.2247. And in the same way, I get the square root of 0.5. And I get this point right here as 0.7071. So please choose delta. So for epsilon equals 0.5, delta will be so the first one is, so I have to find the minimum of this difference, which is 0.2929 and
Your camera's
point.
off for me. Your camera's off for me too. Yeah.
Sometimes there is a cable here that creates that. Thank you so much for letting me know. So one of them is 0.2929 and the other one is 0.2247. So
And
this.
what you did was you subtracted the differences.
So how do I get the distance between these 2 points?
You subtracted it.
From
Absolute
1.
value.
Oh.
From 1, I subtract 0.7071 to get this distance.
It's off again. Your camera.
Yeah, I'm not sure. Let me see what is going on here. It shouldn't be doing that. So how do I get this distance? Is from 1, I subtract this distance to get this distance. In order to get this distance, from this distance, I subtract 1. So then, therefore, what is delta?
.2247.
Thank you. Which part of all this is not clear, or what do you think, or what are your thoughts on this, or?
That explanation helped a lot for me. I don't know about anyone
Me too.
else, but it did.
Okay.
Same, but I just want a second to do the calculation, like on my calculator, just to.
Okay. Anyone else other questions on this or anything else? Anything else? Okay, so then we'll continue. There are two other things that I would like to do from 2.5. I just wanted to mention continuity from the left and continuity from the right. Continuity from one side. Okay, what does that mean? So a function, if we have a function like this, it has a jump, it's discontinuous. However, because the limit from the left, and let's say this is a, of course, the limit from the left of a equals the function value at that point, we will say that this is continuous from the left. Continuous from the left. So how do we write that? We write that the limit as x approaches a from the left, of course this is f of x, is the function value at that point. So continuity from one side, or one-sided continuity. If the function is continuous from the right, then the tendency, the limit, and the function value will be the same on the right-hand side. The other thing I would like to show is an example of the IVT in which the interval is not given to us. So we looked at an example last time, wrong section, of course. We looked at an example last time in which we were asked, show that there is a C guaranteed by the IVT, intermediate value theorem. But what we did not do is we did not look at an example in which the interval was not given. So here the interval is given. Beautiful. As you notice, they're all 1 unit interval. But let's look at an example, for example, this one, or this one. Oh no, they're giving us the intervals. I don't want an example with given interval. We don't have any? How come? No. Really? Then we'll make one up, if we can find one. It's an important type of situation in which the interval is not given to us. The removable intermediate value theorem. Okay, so we have something like this. So let's look at, it's a calculator issue. So let's look at 59. That's a good example, any example. So we have cosine x equals x cubed. So the question will ask us, find an interval in which f of x is 0, or solve the equation and find one solution, if there is one. What is f of x? Of course, it's cosine x minus x cubed equals 0. So this equation is identical with this equation. The solutions of this one are the solutions of this one. Why do I need to move this term to the other side? Is because if I want to use IVT, I have to have 0 on one side. There are other ways, but this is the simplest way. Okay, so I have this function. Is this function continuous? So f of x is continuous everywhere as a difference, in this case, difference of two continuous functions, everywhere.
Will there ever be a problem where one part of the function isn't continuous? Like, or is it always
Yes.
going to be continuous?
Yes. So, for example, if you have natural of x minus 7x equals 0, this is continuous only to the right-hand side of 0. So you have to start with continuous on 0 to infinity. But in this case, these two pieces are continuous everywhere. So you have to be careful. It's a very good question. You have to be very careful because if you cannot say that this function is continuous everywhere, because it's not continuous at 0 and it's not defined to the left of 0. So this function, I will say it's continuous everywhere between 0 and infinity. Not everywhere, meaning negative infinity to infinity, like this one. So cosine is defined and continuous everywhere. X cubed is defined and continuous everywhere. So now I do have to find an interval, find a comma b, where there is a change in sign. So how do I do that? I'm going to share my screen. I'm going to plug this in the graphing calculator in y equals, clear whatever we have, and then we plug in. Make sure, please, for calculus, go to mode. Make sure that you are in radian mode, especially when it doesn't matter if you only have cosine. If you only have cosine, it doesn't matter if you're in radian or degree. But if you have cosine x plus a quantity that does not have a trig function in it, you must have the mode in radian mode. So we go to y equals, we plug in cosine minus x cubed. I didn't mean that. Of course, I wasn't looking there, minus x cubed. This is what I meant. And we go back to second and table. So make sure that you go to second and table set, first of all, and you make sure that the independent variable is in the ask mode. The dependent has to stay in auto, but the independent has to be in ask mode. And then we go to second and table, and I'm going to start punching in numbers. So I'm going to punch in 0, I'm going to punch in 1, and I say, yay, that's it, that's all I need. F of 0 is a positive number. F of 1 is a negative number. That's all I needed. So then I will say, so on the interval 0, 1, it has to be 1 unit interval. As I mentioned last time, please don't say between 10 and 20. That doesn't mean anything. It has to be a 1 unit interval. And then I will say from 1 and 2 by IVT, there exists a C in the open interval 0, 1 such that f of C is 0. That's all I wanted to say about